Welcome. My name is Thomas Mitchell. I'm an Azure content author at Cloud Academy, and I have over 25 years of deep IT experience, several of those with cloud technologies. If you have any questions, feel free to connect with me on LinkedIn. The concept of data flow encompasses the initial ingestion of data, any required transformations, storage of the data, and then ultimately analysis of the data. Data flow is essentially about what needs to happen with the data in order to meet business requirements and how it can be used to answer questions about the business. As such, it's important to get this right. Without the right data flow, a business may not be able to find answers that it needs today, let alone answers it might need in the future. Before designing a data flow, you need to determine what data flow requirements there are. Determining data flow requirements requires you to ask and answer lots of different questions. You need to ask lots of questions up front because when you transform your data, you're often going to keep only the information that you care about, dumping the rest. If you don't think everything through, you might very well dump data that you don't care about now, but might care about later on down the road. So what questions need to be asked? Well, for starters, you need to understand the source or sources of the data and what the data is exactly. You'll need to determine what format the data is in and if it's coming from another database. Is it XML? Is it JSON? Is it unstructured images? As you can see, lots of questions about data format. After sorting out the source and format of the data, you need to identify any security-related issues. You need to identify who needs to access the data and what they can do with it. Access controls will need to be kept in place throughout the lifecycle of the data. This is most important when pulling data from multiple sources, because when you do, the source data is likely protected. Dumping all of this data into a shared repository suddenly makes the data available to people that might not need access to it. As such, it's critical that you understand the security requirements of the source data and that you retain that security once the data has been collected. Along with security considerations, you also need to account for auditing requirements. You need to determine if there are auditing or logging requirements for the collected data. If there are auditing requirements on the data, you might be able to use metadata, such as creation data, batch data, modified dates, and such, to track the data as it's loaded. Logging requirements, if there are any, can be addressed with operation counts, insertion counts, stuff like execution times, and even success or failure information for data loads. Storage retention requirements are also an important consideration. When designing a data flow, you need to determine if you need to or want to store the data forever. You also need to determine if the data needs to be stored in its raw format. The answer to this question is often yes, because if you only keep the data that's been transformed or processed, you may find yourself with unanswerable business questions later because the data that answers those questions was trimmed during the processing stage. You'll also want to determine whether there are retention policies that affect how long data is retained. Are there certain policies or laws that require data to be retained indefinitely or for a specific amount of time? It's an important consideration. Another important consideration is GDPR. Does GDPR even apply? Is there certain data that needs to be removed? Is there a requirement that certain data be removable in the future? All important questions to ask. Another key consideration when designing data flows is metadata. If you are going to be analyzing the data eventually, what metadata, if any, is necessary to facilitate that analysis? Additionally, you should consider what business intelligence tools are going to be used to analyze that data, because this will often determine in some part how that data is stored and in what format it's stored in. As you work through all the data flow design requirements, it's important that you also consider existing skill sets that are available. Because there are numerous technologies that come into play when designing and deploying a data flow, it makes sense to consider whether you have the in-house skill sets to support what you're designing. Think about it. If you're going to design a data flow that leverages Python or T-SQL, what good is it if there is nobody in the organization that knows Python or T-SQL? When deciding on what technologies to leverage in your data flow design, think about your team and what skill sets they possess. You might also consider using pre-existing packages that you already have. For example, if you're already using SQL analysis services and SSIS packages, you probably already have data flows and controls defined. It might make more sense to just bring those pre-existing solutions to the cloud, instead of reinventing the wheel with technologies that are foreign to your team. As you define all requirements for your data flow design, think about interdependencies of all the different components. This is important because you're going to need to make all these interdependent technologies work together, similar to that of an orchestrator of a symphony. If you can't make these technologies work together, you have no data flow. Let's start with infrastructure as a service versus platform as a service. When designing a data flow in Azure, you need to consider that almost any service that will be part of the data flow is likely available in Azure as an infrastructure as a service based solution. Generally speaking, this would be mostly virtual machines. What this means is that you could very easily lift and shift your resources from an on-prem environment to Azure. However, by doing so, you also burden yourself with all of the support goodies that an on-prem solution offers, including patching, antivirus, management, etc. However, if you move to a platform as a service based solution, you're going to reduce or eliminate those tedious management and support tasks for your data flow solution, while also improving functionality and scalability. As such, in cases where there is a platform as a service based solution available, the general rule of thumb is to leverage them whenever possible. An example of this would be to leverage Azure Data Factory instead of using SSIS from SQL. When it comes to HA and DR, your data flow infrastructure is no different from any other IT solution. You need to ensure the availability and resiliency of it, which, by the way, takes us back to infrastructure versus platform, because leveraging platform as a service-based solutions, when possible, much of the necessary HA is going to be provided by the service itself, which removes it from your plate for you to deal with. DR, however, is a slightly different animal. For starters, when thinking about DR, you might find yourself wondering what DR you actually need. For example, instead of deploying an actual engineered DR solution, your actual solution might be as simple as recreating any resources that experience an issue, especially in the case of any compute or processing resources that are in play. Ultimately, HA and DR solutions will rely largely on how much infrastructure as a service you're using and how much platform as a service is in play. Now, while HA and DR might be less of a concern, either due to the intrinsic availability of platform as a service offerings or the ability to easily rebuild compute and processing infrastructure as a service resources, data protection is critical. When considering data protection, for data being processed in your data flow, you need to think about where the data is stored and if there is replication available. Network bandwidth and network latency are two key considerations when designing a data flow, especially when data is flowing from an on-prem environment to the cloud and vice versa. I mean, sure, moving data within the cloud or moving data from on-prem to on-prem is generally not an issue. However, when you start traversing both environments with large amounts of data, latency and bandwidth becomes important. To address potential latency issues between on-prem and cloud, you might want to consider an express route, because express route offers the ability to maintain a consistent latency. As far as bandwidth goes, you can typically purchase any bandwidth you need. You just need to be cognizant of what you need. This is obviously based on the amount of data you'll be moving to and from the cloud, and of course at what velocity. Speaking of velocity, you'll also want to think about how you can automate processes such as scaling, scheduling, and even triggering processes. And of course, let's not forget about backups and monitoring. I mean, if you're dealing with data, you need to consider a backup strategy that can protect the data that you're dealing with. The ability to effectively monitor the entire solution as well as the individual pieces of the data flow from start to finish is also important for ensuring a smooth data flow. Another key consideration when working with data flows is control flow. Think about what components or services are going to be ingesting the data initially, what components are going to process or transform the data, and what processes are going to write the data to its destination storage. Security is another key consideration when designing a data flow. Because you're dealing with data, it should be a no-brainer that the data needs to be secured. It's important, especially in cases where data is coming from multiple sources, that people don't have access to data that they shouldn't have access to. That being said, it's critical that ACLs are maintained. As far as pricing goes, because money is no object is typically reserved for the mega rich, the cost of things is always going to be a consideration. The best way to deal with cost and pricing is to determine what the needs are versus the wants as they relate to your data flow solution. With that information in hand, choose the cheapest solution that meets all your needs. So as you can see, there are quite a few components and considerations that you need to think about when designing a data flow. If you're ready to learn about designing and documenting data flows in Azure, let's get started.